So again, we want to graph the following function using the graphing techniques of shifting, compressing, stretching, and or reflecting. Start with the graph of the basic function shown to the right, and then find the domain and range of the function. So notice that our parent function is the square root of x. This is the right arm function, so it's going to take on this look right here. So notice how it does have a domain restriction because of that radical. Notice how we have to have x is greater than or equal to 0 as far as our domain goes. And notice how the graph then goes off to the right. Notice how over here we actually have f of x minus h going on. Notice how the x minus h means this x minus 4, if you will, is going in place of x, and it's creating this function x, the square root of x minus 4. So if it's inside, if you will, since this is inside the function, this is going to be considered a horizontal shift. And since it's a minus 4, we have to think backwards. It's going to actually go to the right 4. So our graph of the parent function should be moving to the right 4. So the one that best mirrors this is this first graph. So again, if I want to verify that, I can go y equals on the calculator, clear these off. If I type in the square root function, so second square root of x, and then come down here and type in second square root of x minus 4, we can kind of see from the graphs, again, the parent function is in blue, our new function is in red. Notice how the parent function has been shifted to the right, and it's been shifted to the right 1, 2, 3, 4. So notice how there is some restrictions here that we see. So notice that as far as domain goes, the far left bound is actually 4. So it goes from 4 to infinity would be the interval notation for that. As far as your range goes, notice how, again, you cannot go below the x-axis. So all your y values are 0 and above. So you can include 0, and you can go to infinity with that as well. So that's how the graph does kind of show. That's how the scale is actually going by twos. It looks like 2, 4, 6, 8, 10, 12. Yeah. So that's how this 4, 0. That's how y was 0. That's the smallest y value. And that's how it does gradually go up, but just not real aggressively, but it does slowly keep climbing towards infinity, just at a very slow rate because of that square root knocking it down. So that would be the graph. Notice how, again, the minus 4 is actually inside the function, which means we have to be thinking horizontal. And since it's a minus 4, we have to actually be going right 4. So if we can do that, then we can kind of pick up on the rest of this as well. But notice how, again, it's easier to identify the domain and range with respect to a graph, because you can then see that left bound and right bound from the graph.